Okay, I guess we can start. Hello, everyone. Thank you very much for choosing my talk for today, because I know there's a lot of interesting talks at the same time. So, demystifying mobile apps architecture. Where does basically the name of the talk come from? In mobile development community, there's a lot of talk about architecture. There's so many talks and there's so much information out there, and it seems like everybody's talking about it, yet at the same time when you talk to developers, there seems to be a confusion about it. And even though I'm doing this presentation now, I am aware, or like at least I felt early in my career, very sometimes maybe overwhelmed and confused and insecure and about what are all these patterns and am I doing it right? What is this thing that everybody's talking about? How can you make it more simple? I'm pretty sure at least once you felt this way. Just for me to get a better understanding of sort of like what you are expecting. How many of you are mobile developers? Cool. iOS? Okay, and Android? Cool. I will, so the talk will cover both iOS and Android. The coding example we're going to have is going to be in iOS just because it needs to be much more explicit than on Android, but I will make the parallels when it's necessary. Cool. So as I mentioned before, there was a time when I too didn't really think about architecture in such a clear way. So this is me back when I started with mobile development a few years back. And I can still remember I was part of the 6 team. And I had to implement this like quite big feature. And I've been working on it for like a week. And I felt happy about it because everything seemed to be working. So I was like, OK, nice. It's time for the pull request. And the reviewer of my pull request was a much more experienced person. And instead of actually leaving comments on my pull request, he just wrote me on Skype, we should have a call. I was like, I guess this is not so good. And basically, we went on a call, and the first things he asked is like, can you please draw a diagram of your solution? Like what you had in mind when you implemented this? And this is basically what I came up with. Like I guess everybody does once. I had just started coding when I got the task and just figured things out as I went along. And I had no big picture in mind. There was no structure. I just did stuff, and then when I actually had to think about it, I was basically implementing technical debt in the project. It didn't make any sense, and it would have been a lot of headaches for my colleagues later on to like understand it and maintain it and so on. Well, in this case, thanks to my much more experienced colleague, we managed to get this sort of fixed because I went back and rewrote all of it that I had been working on for a week. I was not so happy at the time, but now I see it was really worth it. So as I was saying, this is kind of a happy case because we figured it out before it actually made it to the project and before it actually had an impact on all the users and on the developers of the team. But from my experience since during my career talking to a lot of mobile developers and working with a lot of them, I realized that there's always the big picture and a clear structure is missing in a lot of projects, and I think that's really sad. And I believe that all this so many talks about architecture and so many different ways of doing things makes it even more complicated to choose what's right for your project and how should you structure it so that you can build on it and you can maintain it. And this talk is supposed to be about how to think about architecture in a simpler way. I will talk about tools that you can build a foundation of your app. And I will not go through, there will be no acronyms or like really strict rules. I will just talk about 3 simple principles that you can apply to your project and how you can adapt them so that they fit the complexity of your situation. And we will progressively zoom from the bigger picture into the details and get concrete with an actual example. So by the end of the talk, we will be able to sort of check through all of these. So we will have various layers of abstraction. There will be loose coupling of our components. We will be able to write tests for most of our business logic. I will tell you how to make the structure adaptable so that it fits your project. And then we're going to cover where you can start and how to make incremental changes that don't have such a big impact on your development speed, but still can get you to the goal, to the state where you have a clean project that you can test. OK, to make everything more concrete, we're going to start with a small example. As I said, the code is going to be Swift. I hope it's easy enough for everybody to follow. I will explain through it, and I will make the analogies to Android as we go along. So basically, I believe everybody wrote something like this at least once in their career. And if your code still looks like this, don't feel bad. You're in the right place, and we're going to work through it, and it's totally fine. OK, so basically, we have a login ViewController. Imagine the UI. It has an input field, 2 input fields, and a button. And then there's like this callback method when the button is pressed. And what we do, we basically move over. We implement some sort of local checks so that we don't make a backend request with invalid fields. So we check for usually empty email, empty password, if the email is valid, things that we can actually do on the client. Then we can construct. There was supposed to be an animation, but I guess they're not really working. Then we would construct a request with the parameters, whatever the structure is needed on the backend. We have a login URL, and then using the networking framework, in this case, for iOS, it would be something like Alamofire, we would make the request. Once we trigger the request, we're going to do some parsing of the response. If there are some errors, we're going to show different alerts. If there's no error, we can show the user to the app. This example is rather simple, and it might not be so obvious why we actually need to make changes to it or what's wrong with it. But as I'm pretty sure you also know by your experience so far, things always tend to get more complicated as time goes by and as the project further develops. Even in this case, we could add, I don't know, some more checks for the different errors on the backend, or if there's internet connection, or whatever is needed, again, for your application. We will take this example and just change it throughout the talk. And OK, now let's start with basically the first principle, which is having a layered architecture. So this would be the bigger picture of your app. Typically, this is how it would look like for a mobile app. The white line at the bottom is the boundary between the third party and system libraries and your own application. Now, what would be the first? The first layer, it's basically OK, I think it does not. There was supposed to be an animation, but you don't see it, right? Never mind. So like the layer at the bottom, it was supposed to be highlighted, but I think it's not working. It's a layer of wrappers around the third-party libraries and the system dependencies so that you decouple your application from the concrete implementation of those libraries. Why you want to do that is because it is important that changes to the framework don't affect your entire app, but they're sort of localized in one place, so you can adjust there, and then everything else in the application can stay the same. So it's a layer. Oh, shit. Sorry, I'm talking about the wrong slide. Why nobody said anything? OK, so this is this here at the bottom is the layer of your sort of third-party wrappers. It provides, as I said, a layer of abstraction between the concrete implementation and your app. And it reduces the dependencies, and it makes it easier for you to handle changes in these libraries. Now, moving one step up. Sorry. this is the service layer. The service is usually accessing one or two of the layers below. They usually process raw data like JSON or database responses, and they encapsulate it into your domain models. They also might contain some of the business logic of your application. And at the very top, on top of the services, we have a layer of user interaction and user interfaces, which for now we are just going to think of it as our view controllers or activities, and we will we will go into more details later on. Okay. Now, talking about the structure is as important as the communication between these layers. So you want to think of it as a unidirectional communication. I know this might be a little bit confusing because you always need a response back, but the idea is that a request is only initiated from a layer above, and the fact that there are layers above in your structure should be completely transparent to the ones below. So for example, the networking layer should not know that there will be a service calling it. There should be no implicit assumptions over it. At the same time, there should be, in the communication, there should be no skipping of the layers, right? So if you think of the view controller, it should not make the network request directly, but it should ask for the data through the service, and then it's basically transparent if the data comes from the network, or it comes from the database, or it comes from a file that you have stored locally, or whatever it is. Okay, now this is basically the principle, and now we're going to apply it to our example. Again, we're going to struggle a little bit with the animations, but let's hope it's going to work out. First step would be to implement this networking wrapper for our example. Highlighted here is basically the reference to the framework. That's the iOS implementation of it. It can be something like a network manager. And we initialize this in the initializer and then store the reference, right? Next would be to implement the wrapper method around the same, so like the equivalent method in the framework. And in this case, it has almost the same name with the same parameters. And what it does, it creates the request and triggers it. Super easy. Nothing really complicated. Now that we have the wrapper, we can actually extract the service layer, so the one above. In this case, for the login method, I called it authentication service. It can be user service. It can be whatever you want. It has the link to the URL that you're going to call on the backend, and it has a reference to this wrapper that we just implemented so that it can call the request. The login method sets up the dictionary for the parameters, and then it triggers the request. What we can do in the service is also parse the raw error from the network into something more concrete for our application. So we could translate this error into something that's meaningful throughout our app, something like invalid credential or server is unreachable or whatever it is. In case there's no error, we just don't send anything back. Usually, this is how asynchronous code looks like on iOS. You have this completion block, which is called when you're done with your operation. In RX would be the logic that you put in like a flat map or a map or something similar. Okay, now if we go back to the view controller, this is the part here at the bottom where we were making the request and parsing the response and everything. And let's see how it would look like if we would make the changes with the service. So the first part stays the same. Oops, nothing changes. Oh, shit. OK. What changes is that now we call the login method through the service and not through the networking directly. And we don't have any reference to like the URL. We don't have any sort of these hard-coded strings to create the dictionaries. It looks already much cleaner, right? And we basically do the same. If there's an error, we show an alert. If there is no error being returned. We just take the user to the app. So where do we stand after this first step, where basically we just introduce this like various layers of abstraction with the wrappers and with the services. But we're still pretty much tightly coupled with our components, right? Because here in the authentication service, we have a reference to the network wrapper, and there is no way for us to test the login method without actually making a request to the backend, right? Because the wrapper would always have the same functionality, and it would always trigger a request. Let's see how we can solve this. This is basically the second step, which is loose coupling through interfaces and dependency injection. So I've added here in the diagram sort of like these things. There are supposed to be interfaces for each of the layers. And what it does is that it decouples you from the concrete implementation, and it adds another layer of abstraction in your architecture. When it comes to dependency injection, I know this is much more difficult on iOS. There is no real sort of universally supported way of implementing it. It's much better in Android with Dagger. But basically what it means is that you make your dependencies explicit in your initializer and specify them through interfaces. So let's see how that would look like for our example. This is what we had before, the authentication service. And as I previously pointed out, this here is a strong coupling to the concrete implementation, right? So what we can do is we define a protocol for our network wrapper, which is the part on the top. It basically just declares the interface. Nothing will change for the implementation. That's why it's not here anymore. You would just implement this interface. The interesting part is here, where in the initializer we specify the dependency to the network through the protocol, and we store it through the protocol in the class itself. And then the request is still being made in the same way. What we achieve now is that we can actually test the logic in our service, right? Another reason why I chose iOS for these examples is that we also don't really have a native mocking framework. So you basically have to like mock all your stuff by hand, which is not too bad, but it's still something that you have to do. In Android, this would look much cleaner. There would not be so much code. But basically, here we would implement our testing network, which just implements the protocol. We can sort of specify which response we want it to return, and it's just going to return it here in the completion block. And how the test would look like, you would take a reference to this mock network, initialize your service using this object instead of the default one, and then basically you would mock the response that you want to test. So in this case, we want to test a successful login. So the response is just an empty response with no error. This expectation stuff is the way iOS allows you to test asynchronous code. Without this, the test would just run through, and it would just be green all the time because it would never wait for it to complete. So we call the login method with some test parameters. Once the response comes, we save it in some variables, and then we can assert that we didn't get any errors. Obviously, this is a very simplified test because you cannot fit that much code on the slide. But you can imagine you can test if the dictionary is constructed correctly. If when you get a 401, it shows invalid credentials. More things, depending on, like, if you would have a service where you have some sort of sorting logic or some filtering logic, or you have persistence after the request is done to the network, you can assert all of that, which I think is really cool. So now we're basically here. We have loose coupling, and we can actually cover all these services with tests. which is pretty nice because they are the base of our application and they contain a lot of business logic. Now, what do we do with this was supposed to be an animation too, but how about the view layer? How can we test that? Well, the short answer is that we can't really test it. We can't reliably and efficiently mock the same context in which a view is at runtime, the same as we cannot mock the view lifecycle events in a unit test. This is just the way the mobile platforms were developed. And it's a limitation that we have to work, maybe not against, but work together with, right? So if we are not able to effectively test these view controllers and activities, what else can we do? Well, we can basically leave nothing there to test. So we can just extract all the logic away from the views and just leave them as dumb as possible. So they have a label which shows the text. That's the basic idea. So what we're going to do now is extract the logic that we still have in the view controller into view models. And this new layer appeared here in the structure, and what they do is that they access one or more of the services below. They get the response, which is in terms of like domain models, and they put it into a structure that the view can understand and just display without doing any further processing and without any further checks or conditions. In this way, we detach the views from the complete implementation. They know nothing about your domain model. They don't know that they're showing users or that they're showing files or that they're showing anything. They just show labels. And the less logic we take away from the views, the more logic we take away from the views, the less we are affected by the challenges of testing these view controllers and activities. Okay, let's see how this would look like for us. I know this is a lot of code, but we're going to go through it step by step. So this is our login view model for our view controller. We already saw that we want to cover the case where we have invalid, so like empty fields, invalid fields, and we want to show the user that that his credentials are invalid or that the server is down. So that's basically the errors that we could get: empty fields, invalid email, invalid credentials, no internet, and generic. Next is that we make a reference, we specify the dependency towards the authentication service through the interface as we did previously, and we store it in the view model. And then we implement the login method, where we can basically do all the checks that previously were done in the view controller, like if the email is empty, if the password is empty. If all the fields are correct, we can then make the call to the service, and depending on the response, return the right, the right values. And with all this, the view controller will only have basically the call to the view model, and then depending on which error it is, show the different alerts. If there's no error, just move on. I hope it's also for you clear that this is much easier to understand and much easier to follow, even if you were not the one writing the code, because I hope it's pretty clear what. Can you see it? Not really, right? Can you see the code? Yeah? Okay. Yeah, it's clear what states the user interface is in, right? We can show different alerts, or we can just move on. Everything is kind of explicit. Okay. Now, oops, again, my animations didn't work, but now we're basically ready to test the services and all, as much logic as we want from the views. So what should we do next? Basically, write tests and check that we're doing a good job. I know this is a painful process, or it was a painful process if you have been a mobile developer for a long time. But I think it's really possible for everybody to have a project with good test coverage, even if it's a mobile application. Everybody knows why unit tests and automated tests are important. I mentioned here a few points. They're basically the safeguard, the watchdog for your application, right? They force you to think about, to make the expectations of your code explicit. In case you still have tight coupling, that would be really obvious in a test, because you won't be able to, like a network request would be made, so you won't be able to mock it. So then you know what are the areas that you still have to work on. Yeah. And at the end, I hope like having a collection of tests that you can rely on should also give you a confidence in your code, in your releases, and make you feel like, okay, I know that my logic is tested, and then maybe I just need to test the UI. Cool. So we talked about tests and how to basically test everything that we can effectively. Now, there was a point in the list about adaptable structure. So the structure I just presented is quite basic, and I think it applies to every project. But as the projects grow more complex, then you can imagine these view models getting really big, or like the services getting really big. For this case, you would like, an option would be to take away even more logic. So for example, if you have a lot of presentation-related logic, like a lot of conditions for strings and images and colors, you can extract that into a presentation layer. And if routing is a big deal in your application, you can extract all that into a routing layer. This, like the structure that we had with this presentation and routing layer, would basically be Viper, if you ever worked with it. It's just we started from the bottom and not from the top. Now, when you define these layers, it's up to you to decide where do you put it in the structure, and how do you model the communication between them, like who should initialize the router and who should call the presenter and so on. But once you do that, then you would basically be able to sort of like include them in your structure and have a clear way of how to move forward. Okay. So the last point that we still have not covered is incremental changes. Where can you start? The easiest place to start with testing would be with your helper methods and your static methods or extensions. I'm pretty sure everybody has those, and we have them for a reason. It's because they're used throughout the whole application. So actually covering them and making sure they work correctly should already have a big impact on the app. Once you're ready to start basically cleaning up your structure, the first thing to do would be to decouple from the dependencies, from the third-party dependencies and system frameworks. So writing these wrappers just like we did now. Once you have this, you can then move on to extracting the service layer and adding tests for it. Once you have some of the services, you can then pick your most important view controllers and just extract the logic from there in view models and also test those. Okay, so this was pretty much it. As I said before, I think every project can get to a state where it has a clear structure, and even if the structure is not 100% implemented right now, that there is a goal to strive for. So there's like the top of the mountain, which means you have a perfect project, which obviously does not exist because the mountain moves further and further away. But still, the three principles that I covered were having a layered architecture, loosening the coupling between your components with dependency injection and interfaces, and leaving no logic in your view controllers. If you have a good understanding of what your application needs, and you are determined to make a consistent effort towards implementing a clean structure and having lots of tests, I'm pretty sure you can do it in no time. So small steps add up to a big change at the end. And having this clear structure would actually be the same as having having a clean house where everything is organized, where you actually have space to think and to be creative. And it's the same with your software project. Having this structure and the tests to rely on would give you space to focus on what really matters, what's really important for you, which is basically providing the best user experience and making sure your project is maintainable and scalable and that you can fast adapt to the requirements of your application and deliver value to your users. So I encourage you to get out of sort of firefighting mode, where I think a lot of projects and developers are, and take a step back, look at the bigger picture, and then focus on making small steps to get there. I have prepared 2 sample GitHub projects because there's a limit to how much code you can fit on the slides. The Android one still needs a little bit of tweaking because Android Studio was a little bit crap on my Mac. But basically, you can see the sort of like the end result for this login example, and you can see a real project, compile it, and see how it works. You can always get back to me either through the GitHub projects or on Twitter or however you want. I think my contact is on the page of Code Talks. If you have any questions about mobile projects, I would be very happy to hear from you. And if you have any feedback, also reach out. And that's basically it. Thank you very much for your attention.